Welcome back to the channel. My name is TeaCypher, and today we'll continue the process of creating a Simpit panel using Fusion 360. In previous lessons we looked at resources and research we needed to do. We looked at creating the basic metal base plate using Fusion 360. We looked at how to create cutouts and then import them into our model in Fusion 360. And today we'll look at the creation of acrylic plates. Documents we'll be employing are our PDF of the dimensions from the mill standard. This has been transferred to metric as previously discussed by myself. We'll be making reference to the Bible, even though we know there are some errors in it, but we do it being aware of that. And we'll be also making use of our pictures. So, making a start in Fusion 360. At the end of our previous lesson we created this aluminium plate here. I have made some slight alterations to the hole locations, but this does not affect this lesson. So the first thing we're going to do is create a new drawing. And what you see here is the drawing already started. What I've done is I've basically created a representation of the aluminium base plate. So this is referring back to the original PDF dimensions location. This kit provides us with the aluminium base plate that we can use for referencing on our models. So I'm going to start by creating a drawing of a rectangle. Now looking back to the PDF, we can see that there is a dimension of 1.2 from the edge of the aluminium plate to the edge of the acrylic plate. Now it should be noted that this is not a hard and fast rule. You can do whatever you want, and there is definitely variance in different plates for that dimension, but this is sufficient and works quite well in these drawings. So I'm going to create some dimensions in quite rapidly. I'm being a bit more rapid about my process and not doing step by step, as hopefully this sort of thing should be pretty bread and butter to you now from the previous lessons. Okay, so I've created a basic plastic plate which is 1.2 millimeters from all edges of the aluminium base plate. Of course, if this plate was to put in place now, it would go above the Zeus's and wouldn't work. So if we look back to our PDF, we can see there are bites out of it as shown here. So next we're going to go back to Fusion 360 and create those. So I'm going to start by creating a simple line. I'm going to, if you highlight the circle here, you can see how it's got a blue line against it. If I come across, you get a blue dashed line coming outwards. I'm going to select this and bring a line downwards until it intersects with that bottom line. And you can see a little blue square at the bottom, which means it's at 90 degrees. Okay, so that's created our first line. Now we're going to use a new tool called an arc, and we're going to use a center point arc. We're going to select the center point of our Zeus, come out, select the top of our line, come up until it's 90 degrees upwards and click there. Okay, and now I'm going to create a second line, and this one I'm going to purposely do slightly incorrect so I can show you new tools. So the first new tool we're going to look at using here, or new constraint, is the tangential constraint, a very useful one. It basically allows you to get a line to blend into an arc. So if I select the line here and I select the arc, you notice how it becomes one smooth line. Okay, I'm going to repeat the process for this one down here, and there we go. Okay, the next new one we're going to teach you is we're going to look at using horizontal and vertical. Okay, what this does, it basically takes a line, and depending on what it's closer to, either the horizontal or the vertical line, it will snap it to that point. So this now is a horizontal line, while this one I won't be able to snap because it's already got a 90-degree reference here. Okay, so dimensions. We go back to our document, we can see we need a dimension of 6.35 millimeters. So here we go, 6.35, and there we have our basic shape. Now if we go back to our Bible document, we will see there are some images of the real ones, and you notice how there are arcs on it here. Okay, now this document here recommends using a arc diameter of, I believe, 1.58 millimeters. This isn't necessarily reflected in the standard, but it works quite well. So we've got 1.588 millimeters there. So returning back to Fusion 360, what I'm going to do is go use a new feature called fillet. So 1, 2, and you notice how it's blended those two sides in with an arc shape. And I'm going to repeat up here. Okay, and I'm going to set the dimension as 1.588 millimeters. Bash. Okay, so now we have this nice double curved effect as we saw in the Bible format here. Now I would highlight in this one here, we can see how this is actually the top of it and it curves in and back, and I'll discuss that in a little bit later, but at this time it's not important for what we're doing, because with now ones we can see it definitely does not do that. So we've now created our first bite. Now the next tool we're going to use is called the mirror tool. Now as the description describes it, I hope you understand what it's going to do. It's going to effectively mirror our objects. Now you can select your object before or after you've selected mirror. So I'm going to select mirror, and I'm going to just use a left click and right drag to select most of our items we want. I'm going to just deselect that one there and just deselect that point there. Okay, so we've got, basically we have all parts of this arc here. And now what I'm going to do, I'm going to select the line I want to mirror in. I'm going to select this line here, and now we can see it's transferred the geometry up here. Okay, and I'm going to repeat that procedure for the rest of it. Sorry, so I'm going to select mirror, select the items you want to mirror. So I'm going to select those. I'm going to select those. I'm going to then select these ones down here, and then these ones down here, and I'm going to mirror in the vertical plane. This is where construction lines becomes really powerful and allows you to rapidly produce geometry. And now, as you can see now, we actually now have our 4 bites. Okay, and what I'm going to do is I'm going to use the trim feature to bring it back so it's only the material we want. Okay, and now finish sketch. Okay, so next step is I'm going to extrude it out, and the acrylic I'm going to be using is 3 millimeters thick. And there we have our basic plate of acrylic. Now, next stage is we need to work out how we're going to join our acrylic plate to our aluminium base plate. So if we look at the pictures, you can see in this we have 2 fixing points, and I do apologize I can't highlight it in this video, on the bottom left of the panel and top right of the acrylic panel, which connects the acrylic top plate, or glass top plate as it would be potentially in reality, with the aluminium base plate. Now the bolts that are used in real life actually have a aluminium shaft so that you can't over compress them, causing the acrylic to crack. Now how are we going to do that? That's the first question. So what I'm going to do, and this, if you remember back to a previous lesson, going back to this, I'm going to take, I suppress this feature here, this hole feature. So if I unsuppress it, we now have 4 holes. And if I go back into my original sketch, you can see the points where those holes were based. So I've put them 8.5 millimeters outward bound of the deduce points at a width of 115 millimeters. Okay, this is how I'm doing it. I want to reiterate, this is my choices and my process. Is it correct? Technically, probably not. It's not an exact copy of what you see in reality, but for my manufacturing process, where I'm going to use these holes as a fixed reference to assemble the parts together, and also how to jig them onto a fixturing for machining, I'm going with a standardized set of these sort of dimensions to allow me to make best use of the fixturing I've got and make it a repeatable process. If you want to be dead on correct, please do go ahead. You will have to adjust your manufacturing process appropriately. So with that finished sketch, I'm just going to show you how this hole was created. So if I edit this hole feature, you can see that it's got the 4 points selected. It is a ISO metric thread with a size of M4 or M4 by 0.76H class. That's getting rather technical. It's a simple hole design, not counterbored, not countersunk, with a tapped thread, with a full thread, and we are going all the way through, so this part doesn't matter too much. And I haven't bothered to model it. I can model it, but yeah. So I've copied down those dimensions, and what I'm going to do now is I'm going to go back to my acrylic, and I'm going to create a new sketch. So I'm going to create a new sketch. Actually, I'm not. I'm just going to go back and edit the old one because that will work better. Edit sketch, and I'm going to create in a single point. Okay, and there we go. And I'm going to dimension it. And you will notice that with this dimension, because it's not on an obvious horizontal or vertical, you can measure it direct line, X in the X profile, the Y profile, or directly between the two. I want it to be in the Y profile, or the vertical profile here. So I just make sure it's the right one, then I left click to place it. And then that dimension there is going to be the previously discussed 8.5 millimeters. Come on, select 8.5 millimeters. Okay, and now I'm going to start cheating because I like to cheat because it makes my life a lot easier. I'm going to just use the mirror feature again. So I'm going to select my point. I'm going to select the mirror line. Done. Okay, and repeat it again. Select point 1, select point 2, select mirror line, done. Okay, so that's put 4 points in, and then finally I'm going to set the distance between those points as 115 as previously discussed. Finish sketch. So now I have those points. Now if you can't see your sketch once you've created your model, you can see this little eye here. This gets you to show or hide the sketch. So I'm going to make sure it's present and visible, and then what I'm going to do is I'm going to create a hole. So I'm going to select the hole tool, okay, and I'm going to select multiple points. So I'm going to select this point here, this point here, this point here, this point here. Now if you can actually do a drag selection if that's appropriate. If there's a whole series of holes next to each other, you can just do your left click, drag a square over it and do that as whatever you wish. Now the hole type I'm going to use, okay, so it's actually going to be a clearance hole. Now if I select here ISO slotted cheese for this, because why not, and I'm going to go for close fit. Now this is put out 3.2, and just so you can understand, normal fit would be 3.4, loose fit's 3.6. I'm going to actually go even smaller. I'm going for a 3.1 millimeter hole, but I'm going to do that going back to simple here and create at 3.1. This is because I'm using this as a positional reference for machining purposes, and to get repeatability I need to be able to put this onto the fixture in, and I know every time I place it it's going to be as close as damn it to exactly right, so that when I hit machine it's not going to cause parts to be misaligned. So I've done that, and if I look here you can see it's actually, I'm going to select through all, and you can see that the direction is correct and it's cutting the hole through the material. So all I've got to do is click OK, and there we have our 4 holes. Okay, and as those 4 holes align up with the aluminum plate, all I need to do is use a M3 in this case, screw or bolt to connect the two. Of course, being careful not to crush them. Yep. So, and that will bring us to the end of that creation part. I'd now like to review some additional information. So what I've done, as I did with the aluminium parts, or aluminum, whatever way you want to describe it, I've actually created a set of drawings ready for you to use. So if I open up the 9 acrylic for here, you can see the part. Okay, again, it's already got the 4 holes in play. You notice in this case it's actually got these extra tangs in place. Okay, and the way this document works is if you edit the edit the sketch, I've actually used a lot of formulas. So like this distance here is actually D1, which is the overall width, minus 2 times the 1.2. So I've done magic stuff, and let's just call it that. But what it means is you can take this document, and if you edit this profile here, you can actually say, I don't want these bits, I'll take those out. Click, 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 click. Okay, there they are, out. Or you can say, I actually want those, but I don't want these middle parts. Those aren't to my taste. And there we go. And you can do whatever you want with it. I would of course recommend that before you move forward with altering it, once you've downloaded it, just to do a save as whatever you want to call it. But yeah, so I hope you find this information useful. In the next video I will be looking at putting the holes into the acrylic plate, and we'll be also looking at putting text in place. So I hope you join me next time. If you want to, please like, subscribe, do all that sort of jazz, and have a good day, and bye for now.